So we're now going to go over two alternate methods of solving systems of equations, which are substitution and graphing. And we're not going to have any cool or funny, goofy examples like we did last video. Instead, we have these two boring ones. But essentially, each method of solving a system of equations has their own strengths and weaknesses, and you should sort of, as you solve more and more systems of equations, you'll learn which one to use and in which specific scenario, and you'll learn their true strengths and weaknesses, and you'll see in this situation, what do I use, anyways. We're gonna start with substitution because graphing usually you don't want to do. It just it's very tedious and it's usually not more advantageous than the other two. But anyways, with substitution, what you're essentially trying to do is find the value of one variable and then substitute it into the other equation so you can find the value of that variable essentially. You'll see what I mean. So if we were to start with negative 12x plus 9y equals 7, for example, I would say that more this is a situation where you would want to use substitution because in substitution, the advantage that it has over elimination, which we went over in my last video, by the way, the advantage that substitution has over elimination is that you don't have to manipulate one of the equations in order to start eliminating. You can just start straight off the bat with one of the base equations and then find the value of one of the variables, then plug it into the other one. So in this case, I would say that substitution would be the way to go because trying to manipulate one of the equations to match the other would simply not work. It would, but you would have to keep multiplying over and over again, and you would have to deal with excessively large numbers in order to start eliminating one of the variables. So you would have to like multiply this second equation by 12 and then multiply this first equation by 9, and then you're dealing with numbers like 108x, and who wants to do that, right? So in order to begin substitution, we have to take one of the equations and solve for one of the variables. So I am going to solve for, um, I'll solve for the variable x because there's a 9x here and a 12y, and 9 is less than 12. So we're going to start by solving for x. So in order to do that, I'm just going to write the equation again down here. Negative 12x plus 9y equals 7. And to isolate just the x, we subtract the y from both sides. Actually, no, we're trying to substitute the y. I'm sorry. So we would actually isolate the y. So I'm gonna add 12x to both sides. So to begin, add 12x. And you have to do it to both sides, remember. So it becomes eliminated on this side, and you get 9y equals 12x plus 7. Now what you do is divide by 9 on both sides, and after doing that, you will get y equals, actually let me do this in another color. So y equals, and we can simplify this fraction down to 4/3 x, and 7/9 just remains how it is. So now we have the equation, or the modified equation, y equals 4/3 x plus 7/9. You'll also notice that this is in slope-intercept form. So when you're trying to find the what's it called? When you're trying to find the value of the y variable, you're gonna have something that looks like slope-intercept form. And after doing this, we can now substitute this value, this expression that we got for y. We can substitute that in for the y in the second equation. So that's what we're actually going to do right now. And so 9x, I'm just going to rewrite the equation first. 9x minus 12y equals 6. So now we substitute in this equation, or this expression rather, for y, because we see that y is equal to that expression. So substituting that expression in for y is essentially just replacing one thing with another of the same value. Once we do that, then we're only going to be left with x's to simplify down, and then we can actually solve for x. So we do 12 times 4/3 x plus 7/9. And that still equals 6. Okay, so now we can distribute the 12 to the 4/3 x and the 7/9. And I'm going to do some quick fraction multiplication here. So 1, 4, that's going to become 16x. And then if we do that to this expression, or fraction rather, 9 divided by 3, 12 divided by 3 is 4. So 28/3. Okay. So we have distributed the 12 to both of these fractions. And remember, it's negative 12. Let me actually make this negative sign yellow so you know that the negative sign is included with the 12. When you see a negative in front of the distributor, you have to remember to distribute that negative to each of the fractions between the parentheses. So minus and 1, 4, so minus 16x and minus 28/3. And that's going to be equal to, once again, 6. So now we can begin to combine like terms and isolate the x's. So 9x minus 16x is going to be negative 7x. And then we're going to add the 28/3 to both sides. And after doing that, we get 6 plus 28/3. After doing that, we can convert the 6 to thirds, and 6 is the same thing as 18/3. So we get negative 7x equals 18 plus 28 is 46. And now we can further begin to simplify this. I'm actually going to make it easier on myself, or yourselves, I'm gonna like multiply by 3 on both sides with the fraction so I can get rid of that. And then we're gonna divide by negative 21. If you already knew how like nested fractions work, you could just divide by negative 7 on both sides, and then you would see that it would already be negative 46/21. But you could also do this. So we're gonna multiply by 3 on both sides to get rid of that denominator. And then we're gonna get negative 21x. Actually, negative 21x equals 46. And now we can divide by negative 21 on both sides. And now we're left with a very weird and improper fraction for our x value. But that is the solution for our x. So now we can move on to our y value. And to find our y value, what we can do is plug this back into, we can really just plug it back into the expression we made. So if we look back into the expression we made, it was y equals 4/3 x plus 7/9. So let me write it again down here. Y equals 4/3 x plus 7/9. Okay, y equals 4/3 x plus 7/9. And now we can plug this x value into our equation here so that we can find the value of y. So we're going to get y equals 4/3 times negative 46 over 21 plus 7/9. Alright, so now we can multiply these fractions together. It's going to be another really large fraction. So, actually, let me look back to here to see if we can simplify. Yeah, I think, yeah, we could have simplified the second equation down by dividing everything by 3. I forgot to do that, actually. If we divided everything by 3, it would have saved us a step. So when you see like when you see that every term in the equation has a greatest common factor, you can divide by that greatest common factor. All of the terms you can divide by the greatest common factor, and then you get a simpler equation with smaller numbers. So really, we could have divided everything here by 3, and we would have gotten 3x minus 4y equals 2. So giving us a smaller equation. But now what we can do is multiply these together. So I think I'm going to need my calculator for this one. Y equals 4 times 46 is going to be negative 184. Or 4 times negative 46, sorry. And 3 times 21 is going to be 63. Four times, let me just make sure. Pull out my calculator here. 4 times 46. Yep, 184. And we now can add that plus 7/9. 7/9 is the same thing as times 7 times 7, 49 over 63. If we were to convert that into a denominator of 63. And now we can do negative 184 plus 49, which will give us a final answer of y equals negative 184 plus 49 is, let me just do that in the calculator. I don't feel like doing that mentally right now. 184, 49. Okay, it'll give us negative 135. So our final answer here is going to be negative 135 over 63. So our solution set to this system of equations was x equals negative 46 over 21 and y equals negative 135 over 63. I don't think this can be simplified any further. Let me just make sure. 135 divided by 7. Nope. 135. Where's the C? 135 divided by 9. Oh, okay, it can actually, since 135 is divisible by 9. So this is not our final answer. Instead, our final answer will be, if we divide both of these by 9, it should be 15 over 7. So that is our y value. Negative 15 over 7. Okay. This shouldn't be able to be broken down, because 46 is not divisible by 3, nor is it divisible by 7, right? Yeah, no, it's not. Okay, so that is how you solve a system of equations using substitution. Now we are going to get into graphing, which honestly most of the time is useless, but hey, if you're looking to try something new, go ahead, honestly. So first we're going to need our coordinate plane to start graphing, which I have so conveniently over here. Let me move this over to the right a bit. Alright, so now if you watched my video about forms of linear equations, you would know that here we have two different standard form equations, and the advantage that you have with standard form equations is that you can easily find the x and y intercepts. So that is how we're going to go about graphing these two lines. So when I said that graphing systems of equations was useless, I mean, it depends. If you're more of like a visual person and you like graphing lines and looking at the solution visually rather than maybe writing it down and then seeing it that way, then maybe graphing couldn't be for you. So let's find the x and y intercept for this first equation here. So negative 12y plus 9y equals 7. And like I said, in order to, I said negative 12y, I'm sorry, negative 12x plus 9y equals 7. So in order to find the intercept value of one of them, you have to set the coordinate, whether it's the x coordinate or the y coordinate, to 0. So first I'm going to look to find the y-intercept, and when you have a y-intercept, the x value is going to be 0. So I'll set x to 0. So then once I do that, we're going to be left with 9y equals 7. And after you do that, divide both sides by 9, and we get y equals 7/9 for our y-intercept. So let me graph that here. Y 7/9 should be like here. I also forgot to mention graphing systems of equations is often not the best, because your answer could be fractional, and like extremely fractional, like the ones that we saw here, negative 46 over 21, and you're never gonna really be able to pinpoint that solution on a graph unless you have a graphing calculator, and you won't really be given a graphing calculator for these problems. So it looks like that's going to be the case here, but we'll just keep on solving. So y equals 7/9 is going to be our y-intercept, and for our x-intercept, we are going to get, we have to set y equal to 0, so negative 12x is equal to 7. So now x equals negative 12 sevenths. So that is our x-intercept, which is right about negative 1 and 5/7. So that's like right about here. So our line is going to go somewhat like that. So now we can do the same thing for our second equation, 3x minus 4y equals 2, and I'll do that one in, how about blue? And now we can set x to 0 to find the y. So negative 4y equals 2. And we get a y-intercept of negative 1/2. And negative 1/2 will be right here. And for x, we're going to set y equal to 0. So 3x equals 2. And we divide both sides by 3, and we get x equals 2/3. So that will be right about here. And now we can connect these 2 points and make ourselves a line. Oops. Right about there. And now after you're done graphing, you're going to realize that both of the lines are going to intersect at one point. Now if the lines don't intersect at all, or if they're actually the same exact line, then that's how you know you have no solution or all solutions, but that I'm going to go over in a later video. Anyways, when they intersect at one point, that's how you know that you have one solution, and the point that they intersect at is going to be your answer, actually. So we're going to mark it in green. And because this is such an obscure point, and we can't really pinpoint exactly where it is just using the naked eye, that's really the weakness of graphing, and that's why you can't really use it for every system of equations unless you're given a graphing calculator which can pinpoint that exact value. So I wish I could tell you the solution to our system of equations here, but our answer is too obscure and fractional to do that. Your x value obviously would be the x coordinate of this point, so that's going to be your solution for the x, and then your solution for the y, or the y value, will be the y coordinate of this point. So essentially that's how you graph a system of equations to find the answer. I probably should have given a more whole number example, or like maybe with halves. I guess we can sort of estimate it right here. We could say like maybe our solution is, I'll say x can be equal to 2 point, we'll say 2 1/3, so that's 7/3. And we'll say the y is equal to 1 2/3, so 5/3. So our answer for this one, or our estimated answer, is going to be 7/3 and 5/3. So that's essentially how you use graphing to find a solution to a system of equations, and this is how you use substitution. So once again, as I mentioned, each of these has their own strengths and weaknesses, and usually I like to use elimination, even if substitution is more beneficial in that situation, because I'm just so used to elimination that I can sometimes do it even quicker than substitution. But normally what you want to do is get very comfortable with using all three of these methods, not so much graphing, because graphing is very situational. But yeah, graphing, it's normally not going to work unless, as I said, you have a whole number solution or a half solution. In my next video, I'm going to go over how to determine if a system of equations is going to have only one solution, no solutions, or all solutions. So I hope you found this helpful, and I'll see you in the next one.